you're going to see on the test, it's pretty much two problems from each of these in a way. I'm going to give you one problem where I have actually drawn it out for you to find the area. Remember, the area is from A to B, top minus bottom. And then if you're I think all of these I'm making it so that you can do it in terms of x. Okay, so I want to do problem number one together. So let's do problem number one together. I have given you the graph, and I say to find the area of the shaded region. You are going to note what is our upper function and what is our lower function, and is it always that is above the other, which it is in this case. So here's our upper function, here's our lower function. And so it's just going to be the integration from an x value of -1 to an x value of +1 of our top function minus our bottom function. Okay, and so we're going to go from -1 to +1 of x squared plus 3 minus x dx. Now this is not one where we can do from the double of 0 to 1 because of the fact that the area on the left is different than the area on the right. So don't make that mistake. You can only kind of double the area if it's symmetric about the x or y axis, which it isn't. So you're just going to do the antiderivative. And so that'd be x cubed over 3 plus 3x minus x squared over 2 from -1 to 1. I'm going to assume you know how to plug things in, so I'm not going to do that part. So remember, it's always top plug in minus bottom plug in. Okay. So our left and right boundaries of the graph have been given as -1 and +1. Okay, so whatever the area. That's a very good question. I did send these, set these up so they are in terms of x's, so it will always be left to right. Yeah. So let's do one where we actually have to draw the pictures. Let's do now together 10 and 11. So 10 and 11 says sketch the region bounded by the given curves and find the area of the region. So for 10, y equals x and y equals x cubed. And then for 11, y equals the square root of x and y equals 1/2 x. Okay, so let's start with 10. Those are just a linear function in a cube. X equals x cubed. If you were to solve that, it is factorable. And those things do, they do touch at +1, -1, and 0. I just moved it over, Okay, so let's draw this picture. No, that's okay. And I'm really going to spread 1, -1 out just so that I get a good region. For many of these, really kind of spread that counting out a little bit, because a lot of them meet up at like 1s and 2s, and so it might be helpful if you do that. So first let's draw our line. So that's your line y equals x, slope of 1 goes through the origin. And then our cube function hits the point 0, 0, 1, 1. At 2, it goes all the way up to 8, so it just goes very quickly. Now, technically, the answer to this problem is 0. We have a positive area, we have a negative area. I'm not going to give you one like that. Let's assume let's make one more little caveat to this. Let's say where x is greater than or equal to 0, so that we only will calculate this little region right here. Okay. So if it didn't have that, the answer would be 0. But because, let's just focus on this area here. So we would go from 0 to 1. What's our top function at all times in that area? It is x. What is the bottom function? Well, actually, it wouldn't be 0 because we would have to do top minus bottom. Never mind, we'll figure it out in a second. But anyway, what is always our bottom function in that region? X cubed. So in this particular one, if we just look at the positive, you're going to get x squared over 2 minus x to the 4th over 4 from 0 to 1. And then I'll let you worry about the plugging in for future reference, okay? So there's number 10. So make sure that you're drawing an accurate picture for all of these as you go through this process. I want to see, I will give you points if your picture's right and even if you set up something wrong. So you do need, I expect to see that picture. Okay? If I have not provided it, you provide it. And then finally, let's look at number 11 for area between curves. So number 11 was y equals the square root of x and y equals 1/2 x. Now, where does the square root of x equal 1/2 x? Okay. Now, we're going to square both sides. When we square both sides, we do get 1/4 x squared. Now, let's move that x to the other side. I like my highest power to be positive. I am going to multiply everything through by 4, just so then it becomes just a little nicer as far as factorization goes. We can factor out an x, and then we're left with 4x minus 1. And so these hit each other at 0 and at 1/4. Okay. So again, very small values that we have to look at. So if we, yes. Oh, thank you. Yes. Thank you so much. I appreciate it. It did seem very strange. Okay, let's go back. Mrs. Hott, when you multiply by 4, you get x squared minus 4x. Thank you, which factors to be x equals x times the quantity of x minus 4 equals 0. So x is 0 and x is 4, where they meet. Thank you, much better. Okay, so when we draw this, I want to really stretch out that 4. So I'm going to go 1, 2, 3, 4, 1, 2, 3, 4. I want as accurate, nice pictures as you can. Now, we know the square root goes at 0, 0, 1, 1, and 4, 2. So let's draw that and try to make it as nice as you can. And then we have the y equals 1/2 x is a line that starts at 0, 0, has a slope of 1/2. So up 1 over 2, up 1 over 2. And so, try to make that nice so that you can really see what's under and what's over. So that's why stretching these out is very helpful. And so we get that little chunk right here. Now, what is our top function? The square root of x. What is our bottom function? 1/2 x. So the integral for this one they meet up at 0 and 1. The top function is always x to the 1/2, square root of x. That's a nicer way to write it when we're integrating or derivating it. And then minus our lower function, 1/2 x. So we're just looking at their points of intersection. No, it isn't from 0 to 1. It's 0 to 4. Wow. Wake up, Mrs. Hunt. Wake up, Mrs. Hunt. Oh. Okay, so now if you do the antiderivative, x to the 1/2, if you add 1, is going to become 3/2. And so put that 2/3 out in front. And then this is going to become x squared divided by 2, which would make that 1/4 x squared. I do want to plug into this one just so I can remind you how 3/2 powers work more than anything else. So it'd be 2/3 x 4 to the 3/2. I would suggest doing the 1/2 power as a square root of 4, which is 2, and then 2 cubed is 8. So that is 8. And then minus 1/4 of 16, which is 4. And then if you do check, you do get 0 every time. And then the rest I think you could do just by yourself. But just a reminder how those works. So there'll be one where I've given you the area and I've drawn the picture for you. And then there's going to be 2 where you have to draw the pictures yourself. Okay. So that is the area section of the test. Yes. No. No, I didn't put any super complicated ones because I just want you to make sure you know how to draw them nicely, find what's the top, what's the bottom. I didn't make them super complicated that we had to integrate in terms of y or anything funky. No, okay. So now let's talk about volume. Now, volume, I did give you one where I've drawn the picture for you, and then I've given you 2 where you have to draw the picture yourself. Now remember, the main thing, if it is like a disc where we're just rotating and it's going to be a solid thing, then it is just the pi times the inner radius squared. Okay, and then it's going to go from left to right, a to b. And I think I did one simple one around the x and one simple one around the y. So we'll practice doing each of those. But remember, if it's a washer, meaning there's an inner radius and outer radius, that you go from a to b of pi for the outer radius squared minus pi times the inner radius squared. Okay. So, and you can throw that pi out in the front and just leave it in your final answer. But I just think pi r squared, pi r squared, pi r squared.
Okay, like this might be a better question, but how do you tell the difference?
Between the outer and inner?
No, between like if it's a disc or if it's a washer.
If it says to rotate and you have 2 curves, a top and a bottom, so it looks more like the area ones, as the thing that you're rotating has more of like an area where it's not the x-axis anymore, but it's a separate curve. That's when you know. And I'll do one of each so you see. Okay. So first let's do, we're going to do number 2 and number 3. Okay. Well, one I've drawn the picture for you, so I don't count that one. Okay, so let's do number 2, please. There's 3 volumes and 3 areas. One I've given you of each of the drawing. I've drawn it for you, and 2 you have to draw it yourself.
Is there one where we're like rotating about like x equals
1? No, I didn't. I think maybe there's a bonus where you have to rotate about a line, x equals 1 or something. That's maybe the bonus I put on. There's a bonus that's funky. But. Okay, so let's take a look at this picture. So the first thing you want to do is you want to draw the picture as accurate as possible. Now, when you are drawing something about the x-axis, making the equation y equals is really important. So I'm going to rewrite this equation here as y equals negative x plus 1. Now, the fact that they told us x equals 0 and y equals 0, it just means that they are rotating about the x-axis just whatever's in that first quadrant. That's what this means. This means quadrant 1, okay? So just the positive stuff. So if we draw the line y equals x plus 1, we start at 1. The line starts as a y-intercept of positive 1. And then the slope is down 1 over 1. So it's really just this little thing right here. And this is one where it's a solid disk, okay? And so when I draw these, whatever I get up above the axis of rotation, so in this case, y equals x, or y equals 0, I'm sorry, whatever the axis of rotation is, I will draw the exact duplicate down below it, just so that I can visualize what is my radius. So the radius is the line, okay? So when we do this one, once you set it up, it's pretty easy. We are going from an x value of 0 to an x value of 1. Same thing in a way, if we are rotating about the x, you want to look from left to right. X is from lower to higher. And it's just pi times our radius. Now, our radius is this, the height at on the line. So we hit the line. And so it's negative x plus 1 squared. Now, the thing that I would say for this one, this isn't a hard problem. It's just making sure you don't mess up your algebra. Take that pi out in front. When you square negative x plus 1 times negative x plus 1, just make sure you're doing it right. Don't make up your own algebra rules. When you multiply that, you do get x squared minus 2x plus 1. Because you want to multiply it out so that you don't have to use a u substitution or anything gross. It's because now we can just antiderivative it. And so our antiderivative would be x cubed over 3 minus 2x squared divided by 2, which you could just write x squared, plus x from 0 to 1. And then again, I'll let you do that yourself. So that one is a nice one. When you rotate about the y-axis, number 3, you want your equation to be in terms of y instead of x. So that's why you got to be a little more careful with one like number 3. Okay, so let's now look at problem number 3. It says this time we're rotating about the y-axis. Okay, so I want to first, I'm going to draw, what do all of these tell me? What region am I in? Okay, so let's draw a little picture. And let's put all those on. Gosh darn, I can't make a straight line, even when it helps me. Okay, so y equals 4 is probably our top boundary, because we're going from bottom to top now when we're rotating about the y-axis. And then 0, and then 2. So I'm going to make my 8 up higher. My 4 look like it's here. Oh, let's see. 1, 2, 3, 4. Of course it is. But we're getting there. We're getting there. Okay. So that's y equals 4, x equals 0, and x equals 2. Okay. So we're somewhere in here, but we have to think about where would y equals x squared live? Okay. In that little square, in this square that I kind of highlighted a little bit. Okay. So if you plug in 0, you get 0. 1, you get 1. 2, you get 4. So it's this thing here rotated about the y-axis. So when it's rotated about the y-axis, and this one does not have a washer effect, we'll have to find one that has a washer. And so, yeah, there you go. So think about it would be, that would be our, it would look kind of like the top of like a wine glass or a champagne glass or something like that. And the radius, here's our radius, it hits the y equals x squared. But it has to be in terms of y because we're rotating about the y-axis. So the radius is from your axis out to whatever you hit that you're rotating. So it's not your height. So x would be the square root of y. Okay. So it would be from a height of 0, because we're doing y's, to a height of 4 of pi y to the 1/2 squared dy. So if you're rotating about the y, you make your equation in terms of y. If you're rotating about the x, you make your equation in terms of x. Okay. And so when you the square root, the 1/2 power squared is great because it just becomes a y. Let me move this chart. Okay, so the antiderivative of y is just y squared divided by 2, plugging in 0 and 4, and then you got it. Okay, I want to find one that is a washer.
This one would be like the graph we draw, kind of.
Yeah, I mean, so there's going to be 1, I've provided the graph, 2 that you have to draw it. Let me see if there's one that has inner and outer radius. No, they all might be washers. I mean, discs like this. Yeah, I don't think I did actually do any inner outer radius ones. Okay. So now let's talk about the average value of a function. Let's talk about the average value of a function. I am not going to do one where we've done the mean value theorem that results from it. So I was going to, but I didn't do these kind. I only did ones like that. Yeah.
So if we're not reviewing that one, it's not going to be on the test?
Correct. Okay, so let's take a look at 5.5, number 1 and number 2. The formula that you need to know for this is it's the average value on the interval of the function f of x from a to b is the integral from a to b of f of x dx times 1 over b minus a. Okay, so that's the formula you need. Please make sure you know that formula. That's what you're going to need to do to find the average value of a function. Okay, so it's 1 over b minus a times the integral from a to b of f of x dx. So it's just a formula that you need to know for 2 of the problems on the test. So let's do our first one here. This is our a, this is our b, we are given our f of x. So number 1 is just 1 over 3 minus 0, which is 1/3, from 0 to 3 of 1 minus 2x dx. Okay, I shouldn't have to, I'm not going to do the integral of that. You know how to do that. But I will at least write it. 1/3 of x minus x squared from 0 to 3. Remember, it's upper bound minus lower bound. So that's the average value. You just got to give me a number, okay? Let's set up number 2. This is your a, this is your b. So it would be 1 over b minus a. So remember, that negative 2 would become, because you're subtracting it, a plus 2. From negative 2 to positive 2. It isn't, yeah. And of the integral from x squared plus 2x minus 5. So that one would be 1/4 x cubed x cubed over 3 plus x squared minus 5x from negative 2 to 2. Unfortunately, it's not an even or odd function, so you do have to plug the boundaries in for that one. Oh, I was just saying, sometimes if those boundaries are opposites, your answer might be 0, or you might have to do, you could double the area from left to, from 0 to 2. You can't do that. You just have to, you'll have to do that on the test. I'm not going to waste time. Yeah. Okay. The last thing that's going to be on the test is the inverse trig functions. I'm going to give you 2 where you just have to evaluate the exact value from the unit circle. I will not give you your unit circle. You'll have to know them. The values for the inverse trig functions, where you're searching for the values, are from the graphs that you see up on the board. I will provide for you the table of the derivatives of the inverse functions. You don't have to know them. You just need to know how to use them. Okay. But first, let's talk about 1 through 10. You only use the quadrants up on the board when searching for values. Okay. So what do I mean by that? Let's take a look at problem number 1. Okay. If you're doing an inverse sine of 1/2, the sign is positive in the first quadrant. We only have to look in the first quadrant. We only get one answer. Okay, so that's the beauty of this. You only have to find where in the first quadrant would the sign be 1/2. So the sign is your y value. The y value is 1/2 at 30. I want your answer in radians, please. So that would be pi over 6. Now, what I mean by that is if I said, what is the sign of negative 1/2, then if you look up on the board, you only look for the sign values we call the fourth quadrant, the negative version. So the answer would be negative pi over 6. So sine, tangent, and cosecant are really super nice because the positives are the positive version, the negatives are the negatives. Now look at cosine, cotangent, and secant. They're a little bit different. So if we are doing cosine, let's look at number 7. We look for positives in the first quadrant. We look for negatives in the second quadrant. So that's what those pictures tell you, okay? So for cosine and number 7, for cosine, the cosine is square root of 3 over 2 at pi over 6. But if we wanted the negative version of that, the pi over 6 for the cosine in the second quadrant, it's 5 pi over 6. Oh, yes, I'm sorry, thank you. So the cosine of negative square root of 3 over 2, you will look in the second quadrant for a cosine, so the answer would be 5 pi over 6. See the difference as... So for cosine, cotangent, and secant, the negatives are in that left quadrant, the second quadrant, and your positives are in the right quadrant. Yep. So like number 8, that's the same as negative square root of 2 over 2. The sign is negative, it's negative pi over 4. Cosecant is number 2. Let's do number 2 and number 4, and then we'll do number 3. Let's do 2, 3, and 4, and then those are the type that are going to be on the test. Number 2, I do not search in my brain for cosecants. I make that a sign, and then I just flip it upside down. That's 1 over radical 2, which is radical 2 over 2. The sign is radical 2 over 2 at pi over 4. 4, secant. I don't search for secants. What is the reciprocal of the secant? What is the reciprocal of a secant? The cosine. So I would make that the cosine inverse of 1/2. And the cosine is 1/2 at 60, so pi over 3. Now, I want to talk about cotangent, because I did put either a tangent or cotangent on there. If this is radical 3, that's really radical 3 over 1. I think about that as far as unit circle values. What's the point on the unit circle that has radical 3 in it? Either of the points. Radical 3, the only points that have radical 3 in the actual point on the unit circle. Give me one of them. 30. So 30 is square root of 3 over 2, 1/2. So we never see a square root of 3 in any other place unless it has a square root of 3 over 2 and a 1/2. So all you got to do is in your brain or on paper, rewrite that as square root of 3 over 2 and 1/2. The square root of 3 and the over the 2 and the 1 over the 2 made the 2's cancel. So you don't see it. So radical 3 is a trick. Radical 3 is really radical 3 over 1. Wherever the radical 3 is, put it radical 3 over 2. Wherever the 1 is, put it 1/2. Now remember, cotangent is cosine over sine. So you're really asking yourself on the unit circle, where would the cosine be square root of 3 over 2 and the sine be 1/2, and where is that positive? And that would be pi over 6. Where did that one go? Oh, they're right there. Oh my gosh, where did it go? Okay. So the guide about your inverse trig functions will be on the board, so you know where to look for your answers. Don't overthink those. Just say, where did I get that on the unit circle? Okay. And then finally, the last thing that will be on the test is the derivatives of your inverse trig functions. Now, I'm going to concentrate on 3 types: the sine, the cosine, and the tangent only. Okay. So let me give them to you. They're going to be on the board, but we're going to write them down. The derivative of the inverse sine is 1 over the square root of 1 minus x squared. The derivative of the inverse cosine, but you can write that also as the arc cosine. I can write it either way, it doesn't matter. Same exact thing, just put a negative in front. The derivative of a arc tangent or inverse tangent is 1 over 1 plus x squared. Okay, so those will be written on the board. You don't have to have them memorized. You just need to know how to use them. Okay, so all of the ones on the test will be a chain rule or a product rule. They'll have some kind of rule with them. Okay, again, the perfect example is number 18. Okay, let's do number 18 together. It says that our function is the inverse sine of some stuff. So think about what we do for a chain rule. It is the normal rule with the stuff in there times the derivative of the stuff. So the derivative of this, the normal rule is 1 over the square root of 1 minus the stuff squared. So that's all I'm going to write. You do not have to simplify these. So it's 1 over the square root of 1 minus the stuff squared. times the derivative of the stuff. So this would be, if there's a function here, you just put the function in. That's all I need you to know. And I will give you this. I will give you all three of those. I just want you to know how to use the chain rule with them and maybe a product rule or something. Okay, so let's look at 19. So the inverse tangent of x cubed. So the rule for an inverse tangent, it's 1 over 1 plus the thing squared. So the derivative does that. 1 over 1 plus the thing squared. Now, if you want to make it to the 6th power immediately, go for it. I don't care, you know. Then times the derivative of that thing. Okay. Now, I want to do 20 as the last one for this type. I know, don't do it. Okay, so it's the arc sine of x times the natural log of x. Okay. Now, put a dot between them. That is a product rule. So the derivative of that, the product rule. First, leave it alone. Times the derivative of the natural log. Anybody remember what the derivative of natural log is? 1 over x. Plus the second times the derivative of the first. Well, I'm giving you the derivative of the first. It's just 1 over the square root of 1 minus x squared. So that's the most kind of derivatives I'm giving you. Just, I'll give you the formulas. I just want you to know how to use that formula. We'll have a chain rule or product rule or something of that sort that goes with it. Okay. And then finally, L'Hopital's rule. Okay. Let's look at number 1. If you see this, no matter what type of limit I give you, you should always just check direct substitution. If you do direct substitution, can anybody tell me what you get? So that means I can use L'Hopital's rule. Okay. So we're going to take the derivative of the top. The derivative of the top is just 1. The derivative of the bottom is 2x. Now, this time, we can't use L'Hopital's rule, but we have to use a rule that says anything over, anytime you have, oh yeah, we can just use direct substitution. I don't know what I'm thinking. So now you try direct substitution again. I'm totally overthinking it. And if it works, it works. The answer is 1/4. Okay, so L'Hopital's rule, if you get 0 over 0, take the derivative and then try again. If you still get 0 over 0, take the derivative and try again. Okay, let's do 1 to infinity. Okay, let's do 13. The natural log goes to infinity at infinity. It's just kind of a little swoop going upward. The x squared goes to infinity. So that's an infinity over infinity problem. So that means we can do the derivative of the top, derivative of the bottom, see what happens. So if I do the derivative of the top, it's a chain rule. We have the natural log stuck in a cube. So it would be 3 natural log of x squared times 1 over x. And then if we do the derivative of x squared, that's 2x. Okay. Now let's rewrite that again. We still get infinity over infinity. Natural log of x is going to infinity, whether we square it or whatever. 2x squared going to infinity. Let's do it again. So this time we would get 6 natural log of x times 1 over x over 4x, which we're going to write again. So that would be 6 natural log of x over 4x squared. Still infinity over infinity. So we're going to do it again. But this time we get, finally, the natural log disappears from our problem. We get 6 over, or 6 times 1 over x over 8x, which is 6 over 8x squared. Now, here's what I was doing earlier. I'm so sorry. But if you're going to infinity and you have a 1 over x squared, we learned that that's heading to 0. So that means this answer is 0. So when you finally get to something that we know about the end behavior, that it goes to a number, then we can stop, and then we get that. Okay? So that's what your test looks like. Please study. I'd say it's probably going to take you 2 days. If you can get here early tomorrow or the next day, that might be helpful. Okay?